Okay, so these next set of videos we're going to look at is all about arrays. And up to this point, all the data that we can store in any variable was just one single value, which is useful, obviously. But sometimes we want to pass around multiple pieces of data and use something to store multiple pieces of data. One of our basic structures is called an array, and it allocates a chunk of memory. So in front of you, what you see here, we have a variable that's called grades. It has an integer type, data type, but then there's this parentheses, these brackets with the 5 in it. That's how we declare an array, right there. We're saying we have this variable called grades. It's not going to hold one value, it's going to hold 5 values for us, and they're all going to be integer values. So with an array, all the data it can store has to be the same data type. Right? You can't have a mixture of integers and doubles and strings. It has to be all the same data type. So in this case, they're all integers. I could change the int to a double, and they're all doubles. Change it to a string, and it'll hold all strings, and so forth for any data type. But this one right here holds 5 integer values. Now, the important thing about understanding about arrays and how they actually physically work is kind of important here. So that's what we're going to point out here. We're not going to do a whole lot of code here. But when you declare an array like this, right, and it's the same way we declare any other variable, except we got the size here inside these brackets, it immediately allocates enough memory to hold 5 integer values. And that's what we see here. And that memory is allocated in continuous memory locations, one location after the other. Meaning here that this is an array of 5 integers, and if the array was if the operating system uses 4 bytes for each integer value, that means each of these little squares here with the numbers in them are 4 bytes wide in memory. Alright. The other thing that goes along with arrays are indexes, which are the values here you see below it. And that's what we use to access each of the elements in an array. Alright. Notice it starts with 0. 0 is the very first element in the array. There's 5 elements, but the highest index is 4. It's because it goes from 0 to 4. Right? A little tricky part some people get mixed up on always starting 1. Want to start with a 1, but programming starts with a 0. Right? So the first element is always at 0. And the memory allocation is very important. It has to be in order in the following one value following the other for the array to work properly. The actual variable grades always looks at the very first value, right where the 32 is. So he's holding the address location of where 32 is. That's all he really knows about, this variable grades. Okay, but what was allocated by the system is 5 locations. So let's say 32 is at address 1000. Alright, so to access the 1000, right, all we have to do is grades and then put index of a 0, which gives us the 32 value. Right. It's 4 bytes long, which means then that this 57 is actually at 1004. Because it's 4 bytes wide. This is 4 bytes wide. So if this is at 1000, the start of this 32 value, the next possible location for the integer value is then at 1004. This 57 also takes up 4 bytes, so its width here is 4 bytes. So this 23 is at actually address 1008. 199 is at 1012, and then the last value is at 1016. Right, these are all numbers I'm just making up here. Right? The width of the integers all depending on your operating systems. Right? It could be different depending where you are, what system you're using. But that's important because when I say give me index 2, I want this value 23, and I say give me the value of at index 2, which I'll show you how to do in a second. It takes grades, which it starts here, knows it's at address 1000. It says, okay, well, I want to go up to, I'm asking for an index of 2, so 2 times 4, 4 being the 4 bytes, is 8. So it knows to go to address 1008 to get that value of 23. Right? And that's the important piece of these things being in order, right, when it allocates the memory. So the operating system has to be able to find enough space in memory to take up enough memory for these 5 integer values. Alright, so again, the grades is always looking at the first value and its address. In this case, we're talking about 1000. If we want to get to this 23, we're going to use this index 2, which then says, okay, well, an integer takes up 4 bytes, so from the beginning of the array, which is grades, I need to go 8 bytes to get to it. 4 takes you to the 57, 8 takes you to the 23. Alright, so that's how the array works in the background, and that's how we declare an array. Alright, those are the important concepts there. Let's just quickly take a program here. We'll take that array we just created. Alright, and you see I'm typing it just like I had it on the other page there. So now I have memory allocated to 5 places. Alright, and if you want to get to a value, right, I can do this, and I can assign the value of I don't know what was in the array, but we just put values in there. Right, and I can get to the second one if I want. Right, put the 23 there. We'll do a third one. I don't have to set all the values in the array to a value all at once. Right, I can do it anytime. Right, so that's actually assigning the values in the array. So let's see how we did here. We had 32, 57, 23. So now I'm having in the order 31, 23, and 56. Right? So different numbers than what I had in here, but same concept. This 31 is like right here where this 32 is. 23 is right where the 57 is. And this 56 is now at index 2 where the 23 is. So the other two, indexes 3 and 4, I haven't allocated. So they're currently invalid or have very invalid values in it. Right, so I can assign values to it. I can output values from locations. Right, well, I'll put a couple of them. Oops. Right, I'm going to skip index 1 and just go to grades 2. Alright, those are allocated, and I'm going to show you by accessing grades, which we haven't set to a value yet, for the last element in the array, and I'll put that one. So what we should see is the 31, the 56, and then some crazy value. Alright, so there's the 31 because we set index 0. Then we got the 56 because we set index 2 here. Then I set index 4, which we never set to a value, so it has garbage in it. And that's true of any variable. If you don't assign it a value, initially it has this garbage value here. Alright? So if you start seeing those numbers, it's because you never set the location to a value, whether it's an array or just a regular variable. Now, one of the danger things with C++, it does allow you to go beyond the size of the array. We don't have 10 elements. There is no index 10. There's no index 5, 6, 7, 8, 9, whatever. But the way the arrays work, it knows to start whatever address, in this case grades, is at, do 10 times 4 bytes, which is 40. So it moves from wherever grades is in memory, 40 bytes out, and gets you the value there. Now this can do one of two things. Either give you the value, can crash your program. Right? What you're actually doing here is you're stepping on memory locations. Right? You see this one is not garbage. Right? The last one. That means there's actually something at that memory location. It's probably something valid. Another piece of code, another program running, something that's been allocated to this program. Right? But it's part of the program. It's not an actual value. So if you actually start changing that value, assigning to index 10, you can cause the program to crash pretty quickly. Right? And get not very good results. Right? So again, declaring the array, assigning values to the array, getting values out of an array.